Now that you understand the security phase, right? Now that you understand how this DTLS work and what happens, in the security or securing phase. So we have understood the signaling here, and after that we have understand the connection part, and then we understood how securing these connection happens. Okay, so after this connection, we secure that connection using this DTLS, right? And after this DTLS handshake, we have this keys exchanged from both the sides, right? Now we'll understand how the communication works. Okay, and that's going to be very easy for us. Okay, now that we understand all those parts. Okay, so here till here, okay, we have understood all those protocols involved, right? Yeah, we know that, like, okay, why signaling, for signaling, why we can use WebSocket, why we can use SIP. If you don't understand the SIP, maybe we'll understand in some other session, or we'll create some other tutorial for this, or you can simply google it out, or find some other tutorial on the YouTube or anywhere. So signaling is nothing but simply you exchange the capability information, and then in the connecting phase we understood the ICE phase and stun, turn, NAT, everything, and we established the connection. And the securing phase, we understood the DTLS, how the keys exchange happens, and then you generate the key for securing the connection. Right now, in the communicating phase, the protocols that gets involved is RTP. Okay, zoom in it. Okay, so we use RTP. RTP is nothing but real-time transport protocol. Okay, so RTP is nothing but real-time transport protocol, and along with RTP we also have this companion protocol, which is RTCP. Okay, it is RTP congestion protocol. Okay, congestion control protocol. Okay, so its job is to make sure this RTP works properly. Okay, works fine. Whatever packet is being sent, it is like manager of this RTP. Okay, the RTCP is the manager of RTP. It keeps track of whatever goes around with the RTP. Okay, and just like HTTP, HTTP and HTTPS, just like HTTP and HTTPS, right, we have RTP and SRTP. Okay, so RTP is plain and SRTP is secured. Okay, that's the only difference. Okay, and then we have another SCTP. Okay, so the RTP is used to exchange the media information, media packets, the audio and videos. Okay, and SCTP is used for any type of data. You can say any type of data. It can be text data, it can be binary data. Okay, now you'll say, why can't we use socket and other thing for the data exchange? Because this SCTP provides you way efficient manner of exchanging those data compared to this WebSocket. Okay, it is very efficient in the WebRTC, and it allows you to send huge data also. Like you can set a limit also, like how much data you want to send and all those things. Any form of data you can exchange over this SCTP, and it's very fast. Okay, so now let's understand how this SRTP works. Okay, now we know that, okay, for communication we can simply start sending these RTP packets. Okay, so till here, let me go here. Okay, let me create this like this. This is P1 and this is P2. Okay, let me create this line. Okay, so here we have seen these phases, right? We have understood that there is something called signaling. Okay, we have something called signaling, and we now, after that, we come into this connecting phase and then the securing phase, and after the securing phase we can start communicating. And for communicating we use RTP, right? RTP packets you can start sending across, but then this RTP will be plain, right? It will be unsecured, right? So in order to secure this RTP we use SRTP. Okay, we have, I mean, we saw that we use SRTP, but how this SRTP works? Okay, so here we understood, like, there is something called DTLS, right, which secures the connection, right? It exchanges the keys from both the sides. It has the three-way handshake, but the SRTP doesn't have that three-way handshake mechanism built into it. Okay, so because of that reason only DTLS gets involved. Okay, so DTLS did that handshake part for this SRTP, and it generated those keys. Now what SRTP will do is, it is going to use those generated keys from the DTLS to encrypt these RTP packets. Okay, isn't it interesting, right? So one protocol is dependent on the other, and both of them are supposed to provide security, but this is not going to, create those security keys, right? It is going to rely on some other protocol. So the other protocol created those keys for you, and now you are going to use those public and private keys. Okay, and using those keys, it is simply going to encrypt RTP packets, and it is going to exchange those packets. That's it. That's how communication works in the WebRTC. For the data exchange, we already understood that we have the SCTP. Okay, again, the security part for the SCTP is also dependent on this DTLS only. Okay, so I hope till here everything is clear, how the signaling starts, how the connection phase happens, how it gets secured. So till here, at this point, now you know why WebRTC is called secure out of the box, because even if you don't provide the security, it will be secured at this phase itself. Okay, it is going to do the DTLS on its own, and it is going to secure the further communication. Okay, so here it will get secured, and then the communication starts with all the encryptions. Okay, just note that one important phase: if you don't secure this signaling phase, then this session can be hijacked, right? Someone can perform man in the middle attack still, if you don't secure the signaling phase. That's why WebRTC is recommended to run on the HTTPS only. Okay, HTTPS only. So when you are using HTTPS, whatever signaling you are doing, it will be secured, right? So WebRTC recommends you to use the HTTPS. So during the signaling phase, suppose someone has got this information, okay, this session description, and what it does, it changes fingerprints. Okay, it changes fingerprints and all the ICE informations. Okay, so using those information, if it manipulates those information and creates its own fingerprint and ICE information and sent across both the sides, okay, then it will be able to snoop packets in between, right? So yeah, that's how everything is built into the WebRTC, why everything exists, why all these protocols are there, and how it works together, right? So now I hope you understand everything here in the WebRTC, all these protocols, why it is there, why this ICE is there, why this stun is there, and turn and NAT, why RTP, SRTP, and what are all these protocols and how it works together, right? If you're interested in learning about these things, you can again dig deep and let me know if you want me to create tutorials on that also. I'll create it, right? Okay, so with that, we have understanding of the core concepts of WebRTC till here. Now we understand all the theoretical parts of the WebRTC. Okay, now if you go into the coding part or demo part, you'll be able to understand everything, why this exists, why it happens, and when it happens. Now you'll know. Okay, so all the best, and see you in the next tutorial where we'll go through the demo. Okay, there we will create those peer-to-peer connection. All right, see you in the next tutorial.